It powers the internet, electrifies entire cities, and makes the modern world possible. Yet almost no one knows what it really takes to make copper. Each year, humanity carves 25 million tons of it out of rock, so poor you'd need to crush and process 200 tons just to get a single ton of copper metal. A scale so vast, it moves mountains and runs an industry worth more than $300 billion. But how does lifeless stone become the flawless copper wiring threaded through our lives? This is how copper is made, and inside these massive smelting and refining plants, you'll discover the hidden journey and the high-stakes science that transforms Earth into electricity. Copper is one of the oldest metals shaped by human hands. For more than 10,000 years, it has been worked into tools, weapons, pipes, coins, and, eventually, wires that carry energy across continents. Its unique properties made it irreplaceable. Copper bends without breaking, resists corrosion, and transmits electricity better than almost any other metal. During the Bronze Age, it powered the first great leap in technology. In the 19th century, it became the backbone of the electric age, running through telegraphs, motors, and the first power grids. Today, copper is everywhere, hidden in phones, cars, wind turbines, and the cables that link entire cities. Every year, the world produces over 25 million metric tons. More than 60% of all copper ever mined is still in use, recycled again and again without losing its quality. The global copper market is now worth over $300 billion, driven by a metal that never truly disappears. This is why entire industries exist to extract, refine, and reuse it at a scale few people ever witness. To reach a single ton of copper, nearly 200 tons of rock must be moved. The world's biggest copper producers, Chile, Peru, China, the United States, and the Democratic Republic of Congo, operate mines so vast they stretch to the horizon. In Chile's Atacama Desert, open-pit mines plunge hundreds of meters deep, with benches carved like giant staircases into the earth. Every day, massive drills punch precise holes into the rock, each one loaded with explosive charges. When detonated, the blasts shake the ground, breaking apart ore that contains just 0.6% copper. After the dust settles, excavators swing into action, each scoop lifting as much as 80 tons at a time. Haul trucks, some as tall as a two-story house and weighing more than 400 tons when loaded, crawl along winding roads to the primary crusher. Here, the scale is almost beyond belief. A single shift can move as much material as an entire city block. This is where copper's journey leaves the mountain behind and enters the world of machines and mills. Inside the mill, the journey of copper ore continues with relentless force. Massive crushers bite down, reducing boulders to pebbles in seconds. Next, ball mills, rotating drums lined with steel, grind these fragments into a fine gray powder. Water and chemical reagents are added, creating a slurry that flows into flotation tanks. Here, air is bubbled through the mixture. Tiny copper minerals, now coated by reagents, cling to the bubbles and rise to the surface as a shimmering froth. This froth is skimmed off, then dried, forming a dense copper concentrate. At this stage, purity jumps from barely a fraction of a percent to as much as 35%. Each ton of concentrate carries the promise of a metal that will soon carry power through millions of lives. The leftover slurry, called tailings, is pumped to secure dams, where it settles safely out of the production line. What remains is a feedstock ready for fire, the next step in copper's transformation from stone to metal. Inside the smelter, copper concentrate meets temperatures as high as 1,300 degrees Celsius, hotter than volcanic lava. The process is almost self-fueling. As oxygen-enriched air blasts into the flash furnace, the concentrate ignites in a violent reaction, releasing enough heat to keep the fire raging without extra fuel. Silica sand, called flux, is added to bind with iron and other impurities. In seconds, the molten mass divides. Slag, filled with unwanted minerals, floats on top. Below, a dense layer forms. Copper matte, glowing orange, holding 60 to 70% pure copper. The chief metallurgist watches the separation through heat-resistant glass, scanning for subtle color shifts that signal the right chemistry. Each tap of the furnace drains out matte at just the right moment, a stream of liquid metal flowing into waiting ladles. This is the first true divide. Waste rises, copper sinks, and the journey from rock to metal takes its boldest leap. But even now, the metal is only halfway pure. More fire lies ahead. Molten matte leaves the converter as blister copper, a metal so pure it shines with a reddish glow. Yet its surface is pocked and rough, marked by the escape of sulfur gas. This is where the journey slows and patience takes over. Blister copper, now around 99% pure, is cast into thick anode plates, each one weighing more than 300 pounds. These plates are lowered into deep baths filled with acid and dissolved copper salts. Across each tank, thin sheets of pure copper, called cathodes, wait to receive the final metal. When electric current flows, copper ions break free from the anode and drift through the liquid, pulled toward the cathode. Over 7 to 10 days, copper builds up atom by atom, forming a flawless sheet. Each finished cathode weighs about 100 kilograms and contains copper so pure it's measured to 4 decimal places, 99.99%. At the bottom of the tank, a dark sludge collects. Hidden inside are flecks of gold, silver, and rare elements, reclaimed from what began as waste. In this quiet, electric alchemy, the metal achieves its ultimate perfection, ready for the world beyond the refinery walls. Intense heat returns as pure copper cathodes enter the next phase. In the casting hall, these sheets are melted once more and poured into billet molds, thick, solid bars weighing hundreds of kilograms. While still hot, each billet moves to the rolling mill. Massive steel rollers flatten the metal, stretching it into long, continuous rods. The process is relentless. Machines press and elongate the copper, reducing it from thick bar to slender strand in a matter of minutes. Next, drawing benches take over. Here, copper rods are pulled through a series of dies, each one narrower than the last. The metal thins and lengthens, transforming into wire as fine as 0.2 millimeters. At this scale, a single strand can stretch for kilometers, but the journey isn't finished yet. To prevent brittleness, the wires are annealed, heated and cooled in precise cycles, restoring their flexibility. Coiling machines gather the finished product, ready for the tests that will decide if each strand is worthy of carrying power to the world. Every strand of copper wire faces a final test before it leaves the factory. To reach the world's power grids, each coil must meet the international annealed copper standard, 100% conductivity, no exceptions. Engineers run high-frequency eddy current sensors along the wire, searching for hidden cracks or microscopic flaws that could interrupt the flow of electricity. Throughout the process, non-destructive tests confirm that the metal remains pure, flexible, and free of inclusions. Only copper that passes these checks is labeled and certified for shipment. Each coil carries a unique code, linking it to its test results and production batch. Reliability is not just a promise. It's measured, recorded, and proven, wire by wire, before copper ever leaves the plant. Today, more than a third of the world's copper supply comes from recycling. Old wires, motors, and electronics reborn without losing a single % of conductivity. At the Boliden Rönnskär smelter in Sweden, closed-loop systems melt scrap and new ore side by side, while wind-powered furnaces and water recycling cut carbon emissions per ton by nearly half compared to older plants. Sulfur gases, once a threat, are now captured and sold as sulfuric acid, turning waste into profit. As global demand rises, these innovations keep copper in constant circulation, ready to power the next generation, again and again. Every year, over 25 million metric tons of copper are mined, refined, and shipped worldwide, powering cities, industries, and daily life. This documentary has shown how copper's journey spans continents, from ore grades as low as 0.6% to finished wire tested for 100% conductivity. More than 60% of all copper ever mined is still in use, thanks to near-perfect recyclability and a global recycling rate now exceeding 35%. Yet, as demand rises, questions remain about securing future supplies while minimizing environmental impact. Not all data on proprietary refining methods or closed-loop recycling is publicly disclosed, and the exact pace of green smelter adoption varies by region. What is clear, copper's essential role is unchanged after 10,000 years, and its production links ancient skill to modern innovation. As the world moves toward renewables and electrification, copper's story continues, measured in the wires that connect us all.